So this will be part C of problem number 4 from the 2013 AB exam. It's also on the BC exam, and in part C here it says to determine on what open intervals, on the open interval 0 to 8, is the graph of f both concave up, or excuse me, concave down and increasing, and then explain your reasoning. Well, a function is going to be concave down if its second derivative is negative. So we need to know where our second derivative is negative, and a function is increasing if its first derivative is positive. So we need to know where this and this happen simultaneously. F prime of x is greater than 0. The way that I'm going to go about this, which you don't necessarily have to do, is by making a sign chart. A lot of you are probably going to be able to do this just by looking at the graph and answering accordingly, but what I'm going to do is I'm going to go with a sign chart here. And I'm going to make two different sign charts. I think if we totally kind of see where the function is increasing and see all intervals where the function's concave up, this should be pretty simple to do. So I actually made the sign chart for the first derivative back in part A, so I'm not really going to explain it very much here, but the first derivative is equal to 0 at 1, at 4, and at 6. And we determined that the first derivative was positive there, negative there, and positive there. So our function is actually going to be increasing for the majority of this interval. It's going to increase from 0 up to 4. It does level off at 1, but it doesn't change from increasing to decreasing as we cross that point. So it's really increasing from 0 to 4, and it's also increasing from 6 to 8. Now we need to know where it's also concave down. So I'm going to also make a sign chart for the second derivative here. And it's going to be for the interval from 0 to 8 again. And I need to put points onto this number line that the second derivative is either equal to 0 or undefined at. I need to put places where the sign of the derivative could potentially change, and the sign of the second derivative can't change unless it's first 0 or undefined. So this is a graph of f prime, right? And the derivative of f prime with respect to x would be f double prime. So when you're looking at a graph, on that graph, slopes of tangent lines are really what give values of that function's derivative. We're looking at a graph of f prime. The derivative of f prime is f double prime. And if we want to know values of a derivative of a graph, we're going to look at slopes. The slope of the tangent line to f prime is negative from 0 to 1, and then positive from 1 to 3. So the sign of the second derivative does change as we cross the x value of 1. We have negative second derivative indicated by the negatively sloped tangents on the interval from 0 to 1. We have positively sloped tangents from 1 to 3. So the sign of the second derivative is going to be positive on that interval. We have negatively sloped tangents from the x value of 3 until the x value of 5, right? All these tangent lines on this piece of the graph would be negative. So from 3 to 5, we have negatively sloped tangent lines. And then on the interval from 5 up to 8, we have positive slopes for all of the tangent lines here. The first derivative is increasing on that interval, so we're positive there. So the sign of our second derivative is now in place. Our function is increasing. Wow, that was supposed to be a positive slope, and it definitely looks like a vertical slope, or a no slope. So increasing, decreasing, increasing. And then we're concave down, concave up, concave down, and concave up. Where are we both concave down and increasing? Well, we're concave down from 0 to 1. We are increasing from 0 to 1. So both things happen on the interval from 0 to 1. We're concave up from 1 to 3. But we are concave down from 3 to 4. And our function increases from 3 to 4. So we're going to be concave down and increasing from 3 to 4, as well as 0 to 1. And let's see, any other intervals? Well, we're concave down from 4 to 5, but we're decreasing from 4 to 5, indicated by the sign of the first derivative. And then we're increasing for the rest of the graph from 6 to 8, but our function is going to be concave up from 5 to 8. So these would be the two intervals where your function is both concave down and increasing.